Hello guys, hope you are doing well. In this video I am going to explain the implementation of extended Euclidean algorithm. In previous video we have seen its approach and this is a continuation video. So let's get started. So here I am declaring three variables a, b, c. So these a, b, c are going to represent an LDE in the form ax plus by is equals to c, and we are going to take this LDE as input from user. So doing scene A, B, C, declaring few more variables G, X, Y. So G is going to store SCF of A and B, and X and Y is going to store solution of LDE AX plus BY is equals to C. So G will get its value from a function extended Euclidean, which is going to take A, B, X, Y. So it is going to perform two functions. It will calculate HCF of A and B, and it will calculate the values of x and y, which are the solutions of this LDE ax plus by is equals to c. And we have discussed previously that solution of an LDE exists if and only if c is divisible by the HCF of a and b. So here HCF of a and b is g. So if c is divisible by g, then solution exists, otherwise solution do not exist. So in else condition we will write C out solution of this LDE does not exist, and if C modulo G is equals to 0, then solution exists, and solution will be x into C upon G first solution, and second solution will be y into C upon G. So why I am doing here C upon G? So let's find out. So this is the equation that is given to us from user. We have to find solution of this LDE, but we have passed this equation to the function to calculate its solution, that is ax plus by is equals to g. So the function will return x and y for this equation. Let's make x y here, x1 y1, solution here x1 and y1. So using the solution of this equation we have to find solution of this equation. So as here the constant is g and here constant is c, to make g as c we have to multiply it with c upon g. So here also in solution we have to multiply x1 and y1 with c upon g in right hand side, so that equation will be equal. Hence we are multiplying x and y with c and g. Now let's complete this extended Euclidean function. It is going to return SCF, so its return type will be int. Then I am going to write name of function a, b, and x, y. So I am going to take here x and y as reference. I want that changes that are made in extended Euclidean function should be reflected in the main function. So I am making them as reference. And base case for this function is going to be if b is equals to 0. It's going to be a recursive function, so there will be a base case. So if b becomes 0, then we know that solution will be x will be 1 and y will be 0 and SCF will be a. So we will return SCF, that is a, and I'm going to here declare another variable x1 and y1. So x1 and y1 here are the solution of the next step equation. So in the next step equation will become bx plus a modulo b y is equal to g from ax plus by is equals to g. So in the next step it will become this. So here solution will be x1 and y1. So the variables that I have declared x1 and y1 are the solution of the next step equation. So using this solution I'm going to find solution of my equation. So again calling this function to calculate the solution of next step equation, I will pass here b in place of a, and in place of b I will pass a modulo b, and I will pass solution as x1 and y1. So after having called extended Euclidean, I can assume that the solutions of this next step equation will be stored in x1 and y1, and using this solution of this equation I can find solution of my equation, that will be x will be y1 and y will be x1 minus a upon b into y1, and here I am going to return g, that is the HCF of a and b. So now our code is completed. Now we can uh, provide an LDE as input to this code and we can check its output. So let's say I am providing here 10, 6, 8. So it is an LDE as SCF of 10 and 6 is 2 and 8 is divisible by 2. So here solution should be minus 4 and 8. So let's try to run it. I have not declared here G, so let's declare G. Yes, it is showing minus 4. It is a valid solution as minus 4 into 10 is minus 40 and 8 into 6 is 48, and 48 minus 40 is 8, that is C. So now let's provide an input that is not an valid LDE. So let's say 10, 6 and 13. So here SCF of 10 and 6 is 2 and 13 is not divisible by 2. So here output should be the solution of this LDE do not exist. Yes, it is showing that solution of this LD does not exist. So the code is working absolutely fine. Hope you understood the code of extended Euclidean algorithm. So thank you.